would like to thank our sponsor, NTT VC. NTT VC is an independent venture firm formed in collaboration with NTT. Leveraging a unique strategy and deep industry network, NTT VC unlocks doors to relationships that can help founders and startups reach global scale. We also partner with first-time founders to launch startups. All right, the talk. It's Just a Name, right? By Nathan Eades. Eades?
Eades.
Got it. All right. Thank you, Nathan. Kick it off.
Thank you. Cool. Hi, everybody. Good. I was really hoping the mic would be working. So, quick about me. I won't spend too much here. I already know I need to speed talk a little bit. So, Nathan Eades, work for a great company called Permiso, part of the P0 Labs team. Probably heard of us. If you haven't, we're the one with the game when you first walk into the vendor. That's probably how you'll recognize us. Originally from Pennsylvania, now around the Raleigh, North Carolina area, so flew a few hours to get over here. Background, general cybersecurity, threat detection, disruption, research, and then just big into the cloud. So intro, if you didn't read the abstract, so highlighting how a loose nature of AWS Naming Convention allows for various inputs and how that really just affects logging for the most part. How that adds obfuscation, how that can confuse different teams, researchers, engineers, and SOC analysts. So why are we looking at this? Provide insights when reviewing logs, spark ideas of your own. I'm sure I didn't catch something that someone else may have seen. And then discuss remediation and discussion around that as well. So the first section we're going to go into is IAM sanitization or obfuscation. So for this, the AWS Naming Requirements, great documentation, but it does set kind of a groundwork. So must be alphanumeric, includes these various things, must be unique within the account. The second one is interesting, and the reason I have some of the failures there below is actually because just calling out AWS for it, but policies is actually not included in that second bullet. I'm just making sure that it's well known that it is actually included. We'll let them figure that out in a few days when they have their own conference. Second slide here, again, just getting into some of the naming requirements. These ones specifically around policy, policy documents. Second bullet worth noting again, they only mention inline policies, does actually apply to managed as well. But that was just kind of set up for the rest of this. And really what we're going to look at, so the anatomy of attack in this case, this is pretty straightforward attack. So you have the compromised IAM user. We'll just say that that was compromised through any means. It could have been exposed credentials. But ultimately, they create the IAM user. They create the IAM customer managed policy. The policy is assigned to the user. Awesome, pretty straightforward there. But we're going to look a little bit closer into what that actually is. So zooming in on the IAM user and taking a quick look at the actual underlying log, what we have is the create user. Username was hidden due to security reasons. Now, why did this occur? Did AWS do this based on what I entered? Or did I do this just for the sake of this presentation? If we take a step back, we look at the customer managed policy, we're going to do the same thing. We're going to take a quick look into this, and what we have for the overall policy name in the end is sensitive data removed. So same question, did I do this or did AWS actually do this based on what I entered? And this is what we're left with. Quick and simple answer, neither of those was true. Those were actually the username, and that was actually the name of the policy. But why? So why could we enter these? One. Two, why does it matter? And then ultimately, what else could we do with this? So AWS sanitization, naming requirements. So why was it possible? Well, pretty straightforward. We already looked at it. I followed every single one of the rules. So is there anything else that controls this? And the unfortunate answer is no. That's everything. So why does it matter? Well, looking back over these, I didn't choose these, of course, at random when I created these names. Looking back over 90 days worth of our own data at Permiso, we have 56 services, 35 million events. That translates to about, I want to say it was 270 actual actions. Looking at specifically hidden due to security reasons and sensitive data removed. And that breakdown there is where we saw it based on those services. So hidden due to security reasons would have been 34 services within the request, 17 services saw it in the request and the response, and so on. So you can kind of see the breakdown of where these occurred, sensitive data removed being lesser of the two. With it being the lesser of the two, it's the easiest one to pull up. So EC2 run instances is one of the areas where we see that. Specifically, we can highlight it, and it's under the user data. User data being, your typical startup script. Why would they want the sensitive data to be removed? Well, that could include credentials, depending on what people put into those startup scripts and any variation of. Moving on, so SSO create token. This one has it all over the place. Again, the last one was around that sensitive input data around a script. These ones are more credential based, so secrets, tokens, and the like. In this case, I'm really just glad that they stuck with one syntax and didn't start changing it up. And then finally, we have create DB cluster from an RDS service perspective. We can see, again, hidden due to security reasons on the master user password. This was where it starts to get interesting when we take a look at some of these in terms of the obfuscation and why I would choose to use those names. One, because it adds that level of confusion, because this is normally what AWS does. Now, this could be from an attacker perspective. This could be from an insider threat perspective. But in this case, also, you have master username. In this case, I have it as test. There's nothing stopping me from making that hidden due to security reasons as well. And then you have an extra layer of that confusion. Was it the password? Was it the username? Which one was AWS? Which one did I do? There's now that mix. Moving on, we'll take a look at AWS managed policy obfuscation. So top left, pretty typical. We have all of your AWS managed policies. Bottom right, I've taken one of those, read-only access, and I've made my own. I match the naming. So same type of idea. And really it's, okay, now we've matched the name. Now we have something that somebody might trust. Why are we able to do this? Just the quick tangent on it, of course, it's around the ARN. Anything managed policy from a AWS perspective has the AWS word in place of the account name if it's made by the customer. And that's really the only thing that's delineating these two different policies. Now, if we start to take a look at this in a log, we have this being attached to, whatever it happens to be attached to from an account perspective. This is the one that I would have created. And again, we have the read-only access. Now, think of the people that might be reviewing this, your SOC analysts and the like. They see read-only access. They might have tunnel vision. They might focus right here. They might not even notice this part to say, hey, or even know to question whether that was AWS or if it was something that you created. The other side of that is just the read-only aspect of it. Now you've buried something under both something trusted from AWS, as well as just that context of read-only. When in reality, what this was doing was giving this permission. So using the not action, the more advanced type syntax, instead of a star, let's give all access and something easily detectable, somebody having a really long policy giving access to a variety of things, instead, we're going to use the not action. I don't care about translate. So we're going to give everything else but that. Root user. So this one I had planned to add already, but then I had a instance where I actually helped another great research company just make a quick correction to one of their blogs after they did some triage. And what it really came down to was they were doing the triage and they saw some failed events occur around somebody trying to create a user that was called root. They took that as, hey, you can't do this because root already exists. Well, the fact of the matter is it probably failed because they didn't have the permission or someone had already gone through and created another user called root, because that's really what it comes down to. You have the root user, or you have root and a user called root. And you can always create this. What that comes down to, a little different from an ARM perspective, you're always going to have the account ID, and that's just a matter of you can't call this AWS, or else that would truly be owned by AWS. You have to have that unique per account. Otherwise, though, you just have a prefix for the user slash. From a logging perspective, if you wanted to call them out and just make sure that like a SOC analyst knew what they were looking for quickly, I just wanted to make sure to highlight it. It's actually pretty straightforward. So you have the types where it's root versus IAM user. Principal ID, they might not recognize this as quickly. From a user perspective, there's a true ID. From the root, it's actually just the account number. And then, of course, you have the prefix, which I mentioned before, on the user that's called root, and it actually has a username, whereas true root does not. So just to kind of recap some of what we just looked at. So you have like the hidden due to security reasons, sensitive data removed. The bottom left, I have the 6 pluses in a row. And what that is, I mentioned 2 of the ones that AWS likes to use in their own logging, but that's not it. There's actually a handful of varieties that they use. Probably depends on the engineer that happens to be working on that day, which is a real problem. So the plus 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 is actually really close to 6 asterisks in a row, but since you don't allow the asterisks, I'll just throw some pluses in there and try to get as close to that visually as I can. The other ones listed here, I was just having some fun with it. Yes, you can create a full equation if you want to. Ultimately, if you really like Linux permissions and want to start switching things around, you could go that route as well. And then the one in the center, you can get really close to SQL injection. I couldn't quite get it to work, but if anyone else wants to continue to try with that, feel free. Now, the other variations, again, not shown here. If you stop by and look at the demo, I've shown a few people this. You have these syntax around a full ARN, and instead of colons, because it's not allowed, someone starts throwing dots in there to try to match actual root, and again, trying to bury and show that level of obfuscation to kind of bury what's happening. Other ones you could do, you could match EC2 instance ID, security groups, and any variation of. There are some legitimate use cases for that from like an EC2 perspective. Maybe somebody names it for a role and they want to match the EC2 because it ultimately becomes the instance profile. I would argue you probably don't want to match the instance ID exactly. You probably want to preface that with, this is an instance profile and actually call that out. S3, sanitization or obfuscation. So on a similar vein to what we just talked about, looking at S3 instead. And those requirements are a little more strict, mostly around URLs and its use as a static site. But ultimately, you can do the same type of thing, and I did while testing, just to add in that obfuscation. So sensitive data removed, hidden due to security reasons, and any variation of based on those requirements. There's one advantage here. Nobody else is going to see this happen because I've now taken control of these, so you're welcome. So now I'm going to dive quick into an instance in which Permiso actually helped an organization go through some triage when they had an issue. I'm not going to mention any of the third-party tool names of where this came up outside of ourselves assisting with this. So what occurred was an alert came in from a third-party system. The information included with that was pretty straightforward. We had an unknown account touching the organization account, so the source and the target. And the only other information that the alert actually provided was that of an account ID, a principal ID, and ultimately from a principal ID, you can get the IAM user as well. But focusing just on the account ID level, we started our triage. So what we end up left with is S3 get bucket location, and that was the primary event that we could see. And from that, we can get to the IP address, the S3 bucket name, and the user agent. Now, there could have been more from maybe a data plane level, but that logging didn't exist. So we were left with the management plane. So S3 get bucket location was the only thing we saw. So looking further into that, we'll start off with the IP address. And from the IP address, we end up with the Notorious hacking group known only as the CDC, specifically the CDC out of Georgia. No, the CDC is not actually the Notorious hacking group, but this is who was touching the bucket and that caused this alert to occur. At this point, we can make an assumption that it wasn't malicious. I just couldn't imagine the CDC happened to be attacking this company in any way. So we look at the user agent and we look at the S3 bucket name. And we try to figure out what's actually going on. So AWS PowerShell, that alone sketchy. I don't know too many people using PowerShell to touch AWS. Just doesn't work correctly. Two things don't go together. Matter of fact, the only person I know that might do that is on our team. And then S3 bucket name. This one is the one that stood out to me, specifically because it looked like a programming language for some reason. The other issue, if you remember back to the S3 bucket naming requirements, this is truly how it looked in logging. That's not possible. It has capitalization. It's not a thing. So combining those two things together, I started a basic search. And this is what I ended up with. And this is the main URL that really clarifies things and what was actually happening. So what we're left with is the AWS SDK for .NET, where Amazon.s3.model was the namespace and S3 bucket was the class. So what actually occurred was interesting. Going back a long time, somebody tried to use the AWS SDK for .NET, not truly understanding how to use it, or maybe just making a mistake along the way, finding a snippet of code that didn't quite work the way they expected to. And they actually accidentally created that bucket. So it was just sitting there at the organization for about 11 years, and they didn't even know it existed. It was private, but then they had a different issue. That issue, which was highlighted due to that alert, is over that time, and this was happening periodically. This bucket would just get touched, causing these various alerts to occur over years. And we really thought, hey, we should look into this a little closer. But ultimately, someone ended up doing the exact same thing. Someone found a code snippet. Someone didn't really know how to use it. Somebody ran some sort of command. But what happened was they ended up typing in the exact same thing to touch this bucket, hence causing these alerts to occur. Ultimately, like I said, shouldn't be possible, and it's not today. But that was until about 2014 when that naming requirement was changed to not allow the capitalization. So just kind of calling out why naming requirements and change is a good thing. Now, AWS probably didn't necessarily think, hey, let's fix this thing. They probably didn't care or know this was even happening. But ultimately, it did help fix this. In the end, the organization chose to delete the bucket. I actually told them not to. I said, hey, it's a piece of history. Hold on to that. And in the end, I have control over the lowercase version. It's a lot less fun, but I have it. So detection or remediation around this. Biggest thing first, remediation-wise, call to action to AWS. They have their conference in a few days, why not? So track internally, filter out any of those common used terms to hide sensitive data. We shouldn't have the ability to use them. Make sure that we can't. On a similar note, no reason to allow AWS managed policy names to be repeated. It just causes issues, it causes confusion. Make sure to get rid of that. And that's true for a variety of different things. But after that, I thought to myself, you know what, AWS, and people always think AWS has really good logging. I'll call that into question. So user data, sensitive data removed, master user password, hidden due to security reasons, and all the variations of tokens and everything else where they do the same thing, hidden due to security reasons, all the times where they use their 6 asterisks in a row, any of them. Essentially, it's never necessary. It's not providing any value to anybody. If you're telling me that user data existed, you're telling me master user password was given, you can't tell me what it is. I don't care. So just give me a true false. Yes, this was provided. Yes, somebody changed this. Great. We've now solved part of that. I didn't want to leave the conversation high and dry for actually stopping some of this, so I thought to myself, service control policy. So from a create user, create role, create policy, create group perspective, we can block all these variations and anything in between. Only problem with this is from the perspective of sensitivity, case sensitivity. I can just change it slightly and still get around that because the policy is case sensitive. The only ones where it really affects it well are these last 7 or so. Basically, this is tracking any variation of the special characters right next to each other, just because it's an oddity. I mean, if somebody really wanted to, like an equals equals, they could do it without it too. I was base 64ing names just because I felt like base 64ing names. But this will at least help block some variations if you so choose to do that. One caveat here, works really well from a managed policies perspective, not so well on the inline. And finally, detections, so understanding normal behavior, baselining some various things. Same with the naming convention. You can implement a lot of regex-based matching around all these, including the case sensitivity. And along with kind of that word list perspective, implement kind of a Hamming distance idea. So if someone changes a O to a 0, you're still going to be able to catch that. Real quick, I'll try to speed through some extra stuff here. I talked a lot about how this can affect resources, or your engineers, your researchers, your SOC analysts. But let's consider sending this log, where username hidden due to security reasons, over to everyone's favorite new thing, LLMs. Let's go with ChatGPT and the like. They're going to replace us all anyway. Let's have it analyze this and tell us what it thinks. And what we end up with is the exact same thing that I've been talking about. It thinks this is anonymized. And why is that? Well, most obvious reason, it probably recognizes in this case hidden due to security reasons. It knows that that's AWS's one default, and it sees it, and it believes that everything's anonymized because of it. Or there's the other side and the bigger issue, and that would be, what does it expect anymore? We're all feeding it information all the time, but when it comes to logs or anything potentially valuable, we're obfuscating it on purpose. So now it expects that. It sees things like this, and it's just always going to think that. So whatever you feed it in, it's gonna believe the same thing. And then this talk has been mainly around AWS, but just kind of a food for thought, looking at Google Workspace roles instead. Just a real quick loop through what those look like, and there you have them. Take note of like user management admin, and then they have a type. So like these are all system role. If you create your own, they're custom. And we have here one of the logs getting assigned, and for the value here, the _seed_admin is actually the super admin that we see there. They happen to log it differently. Now, that's fine, but the problem with that is, if I were to go create instead user management admin, do you expect your SOC team to really know that that's not truly user management admin, and that it should start with a underscore and have this weird syntax? And if you don't, that's fine. Well, they can just see that it's a custom role, and they'll look into it, and they'll understand the problem around that. Because ultimately, someone could embed like this one here. I didn't show it, but user admin, management admin actually has full privileges as well. It's essentially a super admin. I just buried it underneath. Is there any way, though, that you can see that in this log? I'll call out Google in the same way. The one thing missing here is the type. So they actually didn't tell you that this is a custom role in their log. And there you have it, where names could cause some problems. So hope everybody enjoyed the talk. QR code should work and bring you right to that URL. Thank you.
All right. Does anybody have questions for Nathan? And I didn't check the Slack, but I assume there's none there either. And you cool. Cool. So have you seen any live attack stuff other than accidents and some of the IR work that you guys do?
Yeah, we have. So that's actually where it first started, was somebody trying to obfuscate how they were naming things, just trying to match things. Actually, really around the managed policy side, trying to embed a lot of it coming from an insider threat perspective. People trying to hide what they're actually doing, embedded in those custom roles instead.
Hiding from their pesky security team.
Exactly.
Any questions? All right, Nathan. Thank you so much. I really appreciate it. Great talk.